Hello, everyone. Welcome back. I'm Steve,
And I'm Scott.
and together we're Backyard Musings broadcasting live. I'm in Apple Valley, People's Republic of California.
And I'm in Utah still. So,
Yes, sir.
and we're talking science today. Definitely.
Yeah, on the screen, we're going to be talking about this planet V Oct AB. It's a planet, and it has two stars, V Oct A and V Oct B. And the weird thing about this is it's going in the wrong direction that scientists would predict that it's going, and we're gonna discuss that.
Okay, and it looks like V Oct A looks like it could be a sun.
Right. Well, stars are suns. I mean,
Well,
that
but I mean not I mean our sun.
our
I mean
sun is a
it's
star. Yeah,
it's putting off a lot of light.
and heat too. So, and these
Okay.
stars are in different developments of where they are. I think Viog B is a dwarf. So, but they still have gravitational pull. I
Okay.
wonder how intense it is on the planet as far as heat goes.
Yeah, I don't know, but it's pretty bright.
Yeah, yeah. Astronomers have confirmed the existence of a rare retrograde orbiting planet in a tight binary star system. Most stars throughout the universe are part of binary or multiple star systems. In these systems, a nearby companion star can make it difficult for planets to form and remain in stable orbits around just one of the stars. These results have been published in the journal Nature on May 21st, 2025. Would you like to know more?
Okay, one thing I want to just clear up is that I'm going to butcher a bunch of words and names in this thing, so just be patient. A research team made up of international astrophysicists led by Professor Man Hoi Lee. I wonder if man is a woman. From the university, I don't know. From the University of Hong Kong's Department of Earth Sciences and Department of Physics, along with I believe this guy is a Master of Philosophy student, Ho Wen Chen, also confirmed a highly unusual planetary discovery. They identified a planet orbiting in the opposite direction of its binary star's movement, known as a retrograde orbit, within the New Octantis
Yeah, new is
binary
spelled NU.
New
Yep.
New Octantis binary system. Their work also sheds light on how the evolution of binary stars may have influenced the planet's origin.
Right. And we're not talking new as in NEW. It's spelled NU. So we're
Right.
pronouncing it new. Yeah.
Okay.
The new Octantis system contains two closely bound stars. You can see the artist rendition here. The primary star, New Oct A, is a subgiant with approximately 1.6 times the mass of our sun. Its companion, New Oct B, has roughly half the sun's mass. Together, our sun's mass. Together, the two stars complete an orbit around each other every 1,050 days. Wow. The stars
Okay. Okay.
round.
Wait. Okay. For my simple mind here, 1.6 times the mass of our sun.
Yeah,
So it's bigger.
it's bigger. Yeah.
Oh, okay.
And Nuoc B is half the size of our sun. But it's weird that these rotate around each other every 1,050 days. These stars rotate around each other every like 3 years, less than 3 years. It's crazy.
Yeah. Evidence for a potential planet in this system first emerged in 2004 when Dr. David Aram, now a co author of the recent study, was conducting his PhD research at the University of Canterbury in New Zealand. He detected an unusual pattern in the radial velocity data, which tracks a star's motion toward or away from Earth, suggesting the presence of a planet.
This signal was consistent with the presence of a Jovian planet of about twice the mass of Jupiter, orbiting around the primary star, Nuac A, with a period of about 400 days. However, the existence of this planet has been controversial because its orbit would be so wide that it can only remain stable if it were retrograde and moved in the opposite direction to the orbit of the binary. So the binary is moving this way, the planet's moving that way, and you got this other star. So these three are doing this little dance. There were no observational precedents for such a planet and strong theoretical grounds against its formation.
To settle the debate, which I didn't know we had one, the research team obtained new high-precision radio velocity observations using the European Southern Observatory, HARPS spectrograph, which I think we've talked about that HARPS
Yeah.
spectrograph before, which confirmed the existence of the planet signal. Quote, we performed an analysis of the new and archival RDO velocity data spanning 18 years and found stable fits that require the planetary orbit to be retrograde and nearly in the same plane as the binary orbit, says Mr. Cho Wang Chen. Oh, that's a different Wang Chen. Okay. The first author of the paper. Or maybe
Yeah, not to be confused with Wang Chung. This is Wan Cheng.
Yeah. Oh, it was Man Hoi Lee that I was talking about. Okay.
Oh, okay.
Cool. Gotcha.
Yeah, so this is really unique. I don't. It's never been reported before. This is really unique. Another key focus of the new study was the determination of the nature of the secondary star Nuac B. The mass of Nuac B suggests that it could be either a low mass main sequence star or a white dwarf. All stars spend most of their lives on the main sequence, generating energy through nuclear fusion of hydrogen to helium in their core. After a star has exhausted its nuclear fuel, its core collapses into a stellar remnant, which would be a white dwarf if the star's initial mass is less than several times that of the sun. A white dwarf has a mass comparable to that of the sun, packed in an Earth-sized volume. Wow.
Okay. To identify which type of star Nuac B is, the research team used the adaptive optics imaging instrument SPHERE at ESO's Very Large Telescope to observe the system. The fact that Nuac B was not detected in these observations indicated that it must be a very faint white dwarf. This suggests that the binary system has evolved significantly since its information, as Nuac B has already ejected most of its mass and entered the final stage of its stellar evolution.
So I wonder if it is this mass. Is it like a crust with a core?
Asteroid
becoming a planet? I mean, it's the size of the Earth, so it's a pretty big, planet. I mean, star, whatever. I mean, it's not ejecting any fuel, so there's no. It seems like it would be like a planet to me.
And we don't even really know if it's round, right, or spherical.
Right, or egg shaped. I would assume that it's symmetrical, spherical, because it's a star, and then it suddenly collapses on itself. So I would think,
or for our flat earthers, it could be flat.
Well, it very could well be. The research team looked into possible primordial configurations of binary, that is, the initial masses of the two stars and the initial orbit of the binary. Quote, we found that the system is about 2.9 billion years old, and that Nuac B was initially about 2.4 times the mass of the sun and evolved to a white dwarf about 2 billion years ago, said Chang. So 2.9 billion and 2 billion. Quote, our analysis showed that the planet could not have formed around Nuac A at the same time as the stars.
The discovery that Nuac B is a white dwarf opens new possibilities for how a retrograde planet may have originated. Quote, when Nuac B evolved into a white dwarf about 2 billion years ago, the planet could have formed in a retrograde disk of many or material around Nuac A accreted from the mass ejected by Nuac B, or it could be captured from a prograde orbit around the binary into a retrograde orbit around Nuac A, explained Professor Man Hoi Lee.
Quote, we might be witnessing the first compelling case of a second-gen planet, either captured or formed from material expelled by Nuac B, which lost more than 75% of its primordial mass to become a white dwarf, added Dr. Trifonov of Centrum für Astronomie der Universität Heidelberg in Germany and Sofia University St. Clement Oritsky in Bulgaria, and a co-author of the paper.
So we're all over the place in these studies, right?
Well, that's good. That's collaboration. That's good.
Yeah. Okay. The key to this exciting discovery was the use of several complementary methods to characterize a system in its entirety, said PD, was that, I don't know, Dr. Sabine Refert of Zentrum für Astronomie der Universität Heidelberg and co-author of the paper.
As astronomers continue to search for planets in different environments, this study highlights that planets in tight binary systems with evolved stellar components could offer unique insights into the formation and evolution of planets.
Okay.
It's really fascinating.
So opposite orbits. Interesting.
Yeah, like, one in the center and it's just moving around. Yeah. Pretty cool.
Yeah. Reverse.
All right, folks. Thanks for joining us. We'll catch you in the morning.
All right. We'll talk to you on the next one. Thanks.